Hey grade 10s, welcome back. Okay, let's do solving a system by substitution, which is the third and next lesson in our Unit 8 notes. Fun fact, this is one of my absolute favorite of all time things to teach. I love this stuff, okay? So I think this stuff is really fun. It's kind of like a fun puzzle. I'm sure I said that earlier in the unit, one of the videos, but I don't remember. But anyways, if I didn't, now you know. I love this stuff. Okay, so the reason we're doing this is because sometimes solving by graphing is not the best option. You might get a really crazy graph or something where they want you to graph a y-intercept of 77 or something, and that's not really good use of our time. So we are going to learn how to solve these systems by two algebraic methods, and the first one is called substitution. Pardon me. Okay, so here are the steps of how to solve this, okay? They are not going to make a whole lot of sense while I run through them here, but as soon as I do a couple examples, I think it's going to click for you. So the first thing we're going to do is we're always going to label our equations, okay? Then once we do that, we're going to pick one of the variables and we're going to isolate it, okay? Once we've isolated that variable, we're going to substitute it into the other equation. Okay, this you need to highlight, okay? A+ importance, could not need to know this more. I will show you why in a bit once we do an example or two. Once you've done that, you're going to solve the equation, and then you're going to be able to figure out the other value. So for example, if you solve the equation for x, then you'll be able to use that x value to find y. Okay, and then we'll check. I won't make you check this, okay? There are no marks assigned for checking, but it is a good idea, especially when you're new to this, to make sure that your answer makes sense, okay? By checking. All right, so let's do this. Solve the following substitution, following system by substitution. It's like a tongue twister that I made for myself. I'm zooming this in super far because I'm going to need as much space as possible because it's hard for me to write with this stylus, as you guys know. But of course you can just write normally on your pages. Okay, so the first thing we're going to do is we're going to label our equations 1 and 2. And then the next thing we're going to do is we're going to select one of the equations and pick a variable to isolate. So I just arbitrarily chose this first equation, but I'm going to say this so many times during this, you can pick either equations, okay? That's why in step 2 it says select one of the equations, not a particular one. Just pick one of them. So if you wanted to pick equation 2 and do this process, that's fine. You're going to get the same answer. I don't care. Okay, so then it says in step 3, isolate the chosen variable. I'm going to isolate y. Okay, and that's again just because. You could absolutely pick x. There are so many choices in this problem solving that you might have chosen something entirely different than me, and you're going to still get the same answer, okay? So once I isolated y, I just moved y over, okay? So if you're wondering, I just did plus y, okay? And that gave me y on its own is equal to 2x minus 5. Now, once I've done that, what we're going to do is we're going to substitute this modified version of equation 1 into equation 2. Okay, so I'm going to write that out so that you have something to look back on. Okay, so plug modified equation 1 into equation 2. Okay, so what that means is we had originally 4 is equal to x plus y. Maybe I'll use some brackets, okay? But now we know that y can also be expressed this way, that y is equal to 2x minus 5, okay? So instead of writing y, we're going to write what is equivalent to y, which is 2x minus 5, okay? Then we can solve this equation, okay? So now we're going to get 4 is equal to 3x minus 5. And then when I solve, I'm going to get 9 is equal to 3x. I'm going to divide both sides by 3, and that gives me that x is equal to 3. Now, if you had a hard time following these steps, you need to practice some algebra, okay? I really mean that because in grade 11, there is no time for, writing out all your algebra steps, so definitely need to review if that was challenging for you to follow, okay? Then the next step is step 6, and it says substitute the value found into either equation to find the value of the other variable. So what we're saying is we already know now that x is going to be equal to 3 in our solution, but we need to find out what is y going to be equal to. And how we do that is we're going to plug our solution, in this case x equals 3, into, I'm going to write this in all caps because it doesn't matter, either equation. The only time it matters is when you do this step. Okay, so once you've found this, then you have to plug that modified one into the other one. That's the only time that it matters. But when you do this step to find the solution, you can plug it into either. I happened to pick to plug it into equation 2 because I think it's easier, but you could do either thing. Okay, and so here we have 4 is equal to x plus y. So in this case, 4 is equal to 3 plus y, right? Because x is equal to 3, which we have from here. Then we're just going to say that 4 is equal to 3 plus y. So when I subtract 3 from both sides, we're going to get that y is equal to 1. And then the last thing that you need to do is state your solution, which is the point 3, 1. Okay. And I'm actually going to modify how we write our answers. Okay, so instead of writing this now, we're going to use some of our notation, our set notation abilities from our previous units. Okay, so we're going to say the set of all points x, y that make this system true is the point 3, 1. Okay, so that's how I want us to be writing our solutions from now on going forward. Okay, and then of course, if you wanted to, you could check your work. That's totally allowed all the time. And like I'm saying, at the start of learning how to do this, I would recommend, because I think that you will find that you don't always do the work right. It's very easy to make a mistake in this process until you have some good practice. So I would recommend. All right, example 2. Same thing. Okay, we're going to solve this system. Oh boy, this zoom tool is not working. Okay, by substitution. So same thing here. Okay, we're going to start by labeling our equations. So you're going to notice, not surprisingly, that I always label the first one 1 and the second one 2. That's just because I'm trying to make my life easy and not hard. Okay, then we're going to pick one of the equations and a variable to isolate. So now I am going to pick equation 2 this time. Okay, just the reason I'm picking equation 2, actually, I do get this question a lot, is because you're going to notice that like this is a very complicated equation, and it will be much harder to isolate x or y in that, and then simplify it. And so because it's so much easier to isolate one of the variables in equation 2 this time, I'm going to do that. Okay, I'm trying to make my life easy, right? That's what we've always talked about, work smarter, not harder. Okay, so I'm going to pick x to isolate this time. The reason I'm picking x is just because last time I did y, so I want to show you that it doesn't matter which one that you isolate. Okay, so then when I isolate x, I'm going to move everything else, so negative y and positive 1 to the other side to get y minus 1. Now, once I have that, I'm going to do the next step, which is to plug this new thing into the other equation, okay? The other one. You cannot plug this back into here. I will show you why in just a second. Let me just finish writing my sentence. Okay, I'm just going to show you what happens if I were to do the wrong thing here, okay? So let's say I was going to plug x equals y minus 1 back into 2. Okay, so I modified 2 and then I'm plugging it back into 2, like equation 2. Then I would get that x minus y plus 1 equals 0, right? But now we know that since x is equal to y minus 1, we can put it in there. Then that gives me y minus 1 minus y plus 1 equals 0. But look, this goes to 0 and this goes to 0. So then we get 0 equals 0. Did that help us at all solve our equation? Absolutely not. It just told us something that we already know, which is that 0 is equal to 0. So like big whoop, you know? So you do not want to do this. You always want to be plugging your modified equation into the other equation. Okay, so that's why I wrote that and told you to highlight it and put it in bold and everything. Okay, so I'm plugging modified 2 into 1. So we know that we have y plus 3 is equal to 1/2. X is equal to something else now, plus 1. And we know that what x is equal to is y minus 1. So I'm just going to plug that right into there. Okay, from there, what I'm going to do is just solve it. So this is going to take a couple steps for some of you and maybe a few more than that for others. That is okay, okay? So I'm going to do BIDMAS. So I have y minus 1 plus 1 inside. So when I have y minus 1 and plus 1, those are going to cancel each other out, right? So I'm just going to get left with y, just one y. And then once I have this, that's like saying y plus 3 is equal to 1/2 y, right? And so I'm going to multiply both sides of this equation. Oh, that does not look like a 2. By 2. Oh my goodness, you guys, what is going on? Okay, super important. When I multiply these sides, I need to make sure I'm multiplying the entire left side by 2, so I need those brackets there so that I'm going to distribute. Okay, now this 2 and this 2 will cancel. Just a reminder that 1/2 times 2 is like 1/2 times 2 over 1. So that gives me 2 over 2, which is just 1. Okay, so that's what happened there. Again, that sort of thing, if you're having trouble with it, you need to practice some arithmetic and algebra, because that kind of thing you're going to need to use next year quite a bit. Okay, so then I'm going to distribute that 2. So I'm going to get 2y plus 6 is equal to y. Right, I have 1y left over. Then I'm going to subtract 2y from both sides, which is going to leave me with 6 is equal to negative y. Okay, and that means that when I divide both sides by negative 1, I'm just going to write this over here, that we get left with negative 6 is equal to positive y. So y is equal to negative 6. Okay, then what we're going to do is we're going to plug solution into either equation. Okay, so now we know that y is equal to negative 6. And we're going to plug that into either of them. So I chose to plug this in this time into modified 2. Okay, so I took modified 2, which says x is equal to y minus 1. And then we are going to just plug that in. So then x is equal to negative 6 minus 1. Okay, so x is equal to negative 7. So then our solution, the set of all points x, y that make this true, the statement true, is the point negative 7, negative 6. Remember to always write your x, y in order here. Okay, not the order you solved it in, but the actual order of x and y. There we go. Voila. Okay, let's do a third and fourth example. And these examples are going to address what happens when the solution doesn't work out quite as nicely. Okay, and so what I mean is when this happens, when we get like this exact, like kind of like pretty, like perfect, just there's a point that makes this true, then that means that if we were to graph these lines, okay, if we were doing the graphing method, we would have graphed them and there would be a point where they overlap each other. Okay, and that exact point is the answer. Okay, but what happens when that doesn't happen? That's what we want to look at next. Okay, what if we were actually graphing the same line twice? Okay, so then every point is the same, right? Every point would make both equations true. Or what happens if we're looking at two lines that never cross each other? Okay, what happens in those instances? We're going to look at those right now. Okay, I actually don't know which one is which. I just drew those in an arbitrary order, but let's take a look and see what happens and how we can identify it. Okay. So, let's pick a color. Let's do this purple. Sure. Did I do purple already today, guys? Oh, yeah. Okay, let's choose blue instead. That sounds fun. All right, blue. Okay, so zooming in again, because, you know, style is life. Okay, equation 1, equation 2. When I did this example in my own notes, I picked equation 1 to modify, and I solved for x. Okay, so I moved everything over to get 2x equals 3y minus 6, and then I divided everything by 2, which gave me that x is equal to 3 over 2y minus 3. Okay, I know there's some fractions, but like life will go on. I promise we're going to be okay. So we're going to plug in to the other equation. So I modified 1, so I'm going to use that modified 1, and I'm going to plug it into the other one, okay? Remember that. This is like the thing I say the most this unit. Plug it into the other equation. Okay. So that means we get y minus 2 is equal to 2/3. I'm going to leave a spot for x plus 3. And in this case, x is equal to 3 over 2y minus 3. Okay. So if you want to like put extra brackets there, you can if that's helpful, but you don't have to. All right, then we're going to get y minus 2 is equal to 2/3 y times 3 over 2y. Now, how did I get that? Minus 3 and plus 3, they cancel out. Then when I look here, I'm going to notice, oh, 3 can cancel with 3 and 2 can cancel with 2, right? So then I'm going to get this funny looking equation where it says y minus 2 is equal to y. And then moving over here, I'm going to subtract y from both sides to get all the y's together. Okay, so then I'm going to get minus 2 is equal to, actually, well, what's my y minus y? 0. And so that is a very false statement, right? Negative 2 cannot be equal to 0. That's not a true statement. And so we are going to write that over here, not a true, let's see if I have space. Yes, I do. Statement. Therefore, there is no solution. Okay, so what this means is that the situation at hand is that we had 2 lines, okay? Hang on, I'm just trying to do this in my head quickly. Okay, so we had 2 lines that looked like this. And, well, essentially this, right? So we had 2 lines that were never going to cross each other, okay? And so then there is no point that's going to make both of them true at the same time because there's no point where they overlap. Does that make sense? I hope so. Usually, this is the point where I would take questions in class, but I know you guys aren't here with me, so really, please message me if you have questions about this, okay? All right, and then the other thing we want to do here is we want to solve the following system by substitution, and then we're going to see what happens in this case. Okay, so again, I'm going to zoom in here. There we go. I like this orange color, actually. Let's roll with it. Okay, like this burnt sienna, maybe? I don't know. Cool. Okay, so we are lucky ducks because this equation already has y isolated. So we don't have to modify anything. So in this case, we just get to go straight to plugging it in to the other equation. It's still, even if you didn't modify it though, okay, super important note, you still have to plug it into the other equation. Okay, so this gives me 2/3. Okay, hang on, let me back up. So we have y in this first, in equation 1. Okay, it's going to be something for y minus 2 is equal to the rest of it. That's what I'm saying. Okay. Just like all the other times. And now I can plug in what y is equal to, which is 2/3 x plus 4. Okay? So, when I simplify the left-hand side, I'm going to get 2/3 x plus 2, right? Because plus 4 minus 2. Okay? And then on the right-hand side, I'm going to distribute that fraction. So I'm going to get 2/3 x. And then, okay, little thought bubble if you need it. Remember that 2/3 times 3 is going to cross-cancel, and we're going to just get 2. Okay, alternately, if you prefer, you can think about this as 2/3 times 3 over 1, which is equal to 6 over 3, which is equal to 2. Okay, either way, it gives you the same answer. Okay, so that's going to give me 2/3 x plus 2. Now, if I move over here, just need more space, so I'm just going to move up here. Alright, so once I have that rewritten here, all nice and not neatly, but I'm trying, then if I subtract my 2/3 x from this side, again, because I want to get all my x's together, that's algebra, right? Then I'm going to get this statement where 2/3 x is actually going to subtract itself as well on the other side. So I'm going to get this statement that 2 is equal to 2. Now, that is always true, right? Like 2 is equal to 2. That is a fact. So we're going to say this is always true. And that means that there are what we call infinitely many solutions, okay? And I will show you the reason for this strange terminology over here on the side. So again, just like last time, okay, we have some sort of coordinate plane situation going on here. Well, I guess that's the end of my page. Okay. And this means that we had some line, y equals 2/3 x plus 4, looks something like that. And there was another line that actually happened to be exactly on top of it. Okay, I know that's not a perfect drawing because my stylus is so crappy, but this means that these two lines are actually the same. Okay, so if you were to draw these two lines on a coordinate plane, like we've been practicing this year, you're going to find that you drew the exact same line 2 times. And that means that there are infinitely many solutions because literally every single point along both of these lines, i.e. that same line, are going to make the equations true because they're all the same points. Okay, so that's what that means. All right, now, this is an important paragraph, okay? I would like to do some starring maybe in your notes or some highlighting. It's worth noting that we can detect without solving, keywords here. Hint, this could be on your assignment, how many solutions a system might have. So parallel lines have no points of intersections, right? That's like the diagram I drew up here. So these are supposed to look parallel. I know it's not perfect, okay? Because they're parallel, they have the same slope, and that means they're never going to intersect each other. And lines that have different slopes, so like if we go back up to this example here, the very first one, we can see that this has a slope of 2, right? And then if I were to rewrite this, it would be y is equal to negative x plus 4. You can see how that has a slope of negative 1, that has a slope of positive 2. So we're going to have one increasing line and one decreasing line, so they are going to overlap each other. Okay, so that's the next hint that we have. Okay, I'm just going to erase this so you can actually look back on your notes and they're not like super messy. And then the last thing is that if you have two equations that are representing the same line, like in this last example that we did here, then there's going to be infinitely many solutions because they have the same slope and the same points on it, and so then all of the points are solutions. Okay, again, message me if you have questions about this. It's easier to explain in person, but I'm doing my best. Okay, we are just going to do this word problem really quick because I bet I'm getting close to my video time limit here, so I'm going to go a little bit quicker through this one. If you have questions, let me know. Okay, so at a particular grocery store, apples cost 3 times as much as bananas. Prices are still decent because you can get a dozen bananas and 10 apples for $10.50. What is the unit price for each, i.e. how much do you pay for a banana and an apple? First thing with word problems, let statements, okay? So we're going to let B represent the number of bananas and A represent the number of apples. Ooh, that's not a good looking letter there. All right. Okay. So the first thing that we want to do is make our equations. Okay. So we can see that apples cost 3 times as much as bananas. So the cost of an apple is 3 times the cost of the banana. And we also know that you can get 12 bananas. So 12 bananas and 10 apples for $10.50. Okay, now you do not have to include the dollar sign in a word problem, and you actually don't even need to include that 0 if you want. So you can just say it's equal to 10.5. All right, now from here we are going to do our solving. Okay, so this is equation 1, this is equation 2. The process is now the same because we have our system of equations. Now you're going to notice in question 1, A is already isolated. Yay! So we're going to plug 1 into 2. Okay, so we're going to get 12b plus 10a, which is equal to 3b, is equal to 10.5. Then when I solve, I'm going to have 12b plus 30b is equal to 10.5, so 42b is equal to 10.5. That means that when I divide both sides by 42, b is equal to 0.25. Okay, so I just did that division on my calculator. So a banana costs 25 cents. And we know that A is equal to 3B, so we can find our banana cost by plugging in that 0.25 that we just found, which gives me 0.75. Okay. Oh dear. Okay, and then the last thing, I know I don't really have space here, but I'm just going to make it work down here. Sorry, everybody. We're going to write our sentence answer. Apples cost 75 cents. Remember to include our units because we're talking about money. And bananas cost 25 cents. Voila. Okay. Hope that made sense, you guys. If you have questions, message me anytime. I would love to chat with you. I think you'll find this stuff fun once you get the hang of it, and I will post an additional worksheet above and beyond this one for you because I think that you will need some more practice than just 4 questions. Okay, I'll talk to you soon.